All right, good morning, guys. So today, don't forget, attendance quiz due by 3 p.m. today. It's on Teams. All blocks, all first, third, and fourth blocks need to submit test 2 answers today by 3 p.m. If you were in fourth block only, you need to submit your midterm answers also today by 3 p.m. Both of those assignments are on Teams. Today we are finishing up topic 6, SAS 4 and SAS 5. So we will be skipping around on a few things, so make sure you're paying very close attention as to where I'm at so you can follow along. Okay, so we're going to start on number 11, page 165. So right here on this animation on Agile Mind, we see that we have the box method, okay, and this is called an area model. This is another way to find my factors. So, it says play the animation to review how to use an area model to factor the trinomial. Trinomial has 3 terms, so we have an x squared, an x, and a constant, where the middle term is rewritten as the sum of 2 terms. So if you notice right here on this area model, we have a 3x and we have a 2x. And those are written as a 5x, okay? So first, I'm going to hit play, and it's going to highlight the top 2 terms. Let me start over so I can pause it. All right, it's going to highlight the first 2 terms. All right, so what you're doing here is you are finding the greatest common factor, okay? So right here, we have an x squared, so we have 2 x's. For a 3x, we have a 3 and an x. So the only thing that those 2 terms have in common are this x, which is where that comes from. Now, it's going to go to the bottom, and it's going to highlight 2x and 6. So now, we highlighted 2x and 6. So 2x is just a 2x, and a 6 is just a 6. Well, you have to think in your head. They don't have any x's in common, but there's a number that goes both into 2 and 6, and it's 2. So our first factor is x plus 2. Okay? Now, we're going to highlight the left side, an x squared and a 2x. They also just have an x in common. After we highlight the left side, we highlight the right side. And we have a 3x and a 6. Well, you have to think, what number goes into both 3 and 6? Well, it's 3. So I have another factor of x plus 3. Now, if I multiplied these, I would get x squared plus 5x plus 6. Okay? Just another way to factor. All right, now on number 11 in your workbook, you have this right here. But it is it's a cubic function. So we have an x squared, a 2x, a negative 2x squared, plus 3x minus 6. So first, what we want to do, we want to highlight the top. So we have 3 x's. And we have a 3x. So the only thing that those two terms have in common is an x. They only have one x in common. So I'm going to drag my x to here. Next, I highlight the bottom terms, and I have a -2, an x, and an x, and a -6. Well, you have to think it's got to be a number because that -6 doesn't have any x's. So what number goes into both -2 and -6? Well, it's a -2. Okay. Now we highlight the first column. And we have an x cubed and a -2x squared. So this column has how many x's together? They have what in common? Well, they have 2. So an x squared goes here. Last, we take this last column and we have a 3x and a -6. Well, what number goes into both 3 and -6? Well, that would be a 3. So my factors here are x minus 2 and x squared plus 3. Now it says blank is the linear factor and blank is the quadratic factor. So out of your 2 factors, your linear is the one that only has 1 x. So remember, that's going to be x minus 2. Quadratic is going to have an x squared, so that would be x squared plus 3. So if I were to multiply those 2 factors, I would get x cubed minus 2x squared plus 3x minus 6. Okay? All right, I want you to flip over to number 12, I think. Let me make sure. Yes. Okay, so now we're going to do grouping. It says when factoring by grouping, you need to be able to factor out a greatest common factor for each group. If you group 2 terms together, there's no greatest common factor. Okay? So, hold on, it's loading. Here's what we're looking at. X cubed minus 2x squared plus 3x minus 6. Okay. Part A says, group the first 2 terms and the last 2 terms together using parentheses. So what that literally means is you have an x cubed minus a 2x squared plus 3x minus 6. So what you're doing, you're taking those 2 terms and you were just grouping them together. So we have first set and a second set. Now, here's my first set. Here's my next set. So on the first set, we want to factor out the greatest common factor. So how many x's is in x cubed? 3. So we have 3 x's here, and we only have 2 x's at -2x. So they have how many in common? They have 2, so I can factor out an x squared I want an x cubed, so I need to add an x minus 2. Over here, this just has an x. And that has nothing. But 3 goes into negative 6. How many times? Okay. So now we're going to go in and we are going to say x squared, x minus 2, 3, and x minus 2. Now, here's the easy part. Factor out the common binomial. Okay. Above, what do you notice that's in common? Both sides has a what? They both have an x minus 2. So we are factoring out that common binomial. We're bringing it down one time. Now, once you factor it out, they're gone. So what do I have left? I have an x squared plus 3. So now I could multiply x squared plus 3 and x minus 2, and I would get x cubed minus 2x squared plus 3x minus 6. So if you flip back to number 11, you'll notice those are the same factors. It's the same problem. One is done using the area model, and one is done by grouping. Okay? All right, on number 13, we are going to do 13A. And we are going to do 13B. So, on 13A, we have 6x cubed minus 4x squared minus 9x plus 6. Okay, so first it says group using an area model. So we're going to go ahead and we're going to draw our box. We have 4 terms. We're going to list them. 6x cubed minus 4x squared minus 9x plus 6. Okay, now, first, remember, you have to look at the first row. So we're looking at this right here. Okay? We have a 6x cubed and we have a negative 4x squared. Now, you have to think, what number goes into both 6 and 4? 2. How many x's do I have in common? I have 2. Okay? Now, looking at the bottom row. A negative 9x and a 6. Well, they only have a number in common. What number is that? Negative 3. Now, we look at the first row. 3 goes into 6 and 9. How many x's do you have in common? 1. You look at the last row. And we have a -2. But do we have any x's in common? Nope. So we have two factors of 3x minus 2 and 2x squared minus 3. I'm not a fan of the area model. I would rather use the grouping, which is what I'm fixing to do. You're welcome to use any of them. So, always want to split your terms up. Just like this. So we have a 6x cubed minus a 4x squared minus, because there's our minus sign, 9x plus 6. Now, here's where you have to be careful. If I was to write this back out, would I get what I started with? This would become a 9x and this would become a -6. But this has got to be positive. So what should I change the sign to on the 6? Should change it to a negative because we know that two negatives make a positive. Okay? So now we're factoring out greatest common factor. So we have 3 x's. We have 2 x's. Now, what number goes into 6 and 4? 2. And I have how many x's in common? 2. I have a 2x squared, but I want a 6x cubed, so I should multiply by 3x. I want a -4x squared, but I only have a 2x squared, so I should multiply by a -2. I bring down my sign, and I think, what number goes into 9 and 6? Well, that's a 3. All right, I want a 9x, but I only have a 3. So I need a 3x. And I want a +6. So I have to have -2 multiplied with the -3. Now, here's how you know your answer is right. This is very important to know. Here's how you know your answer is right. When your two sets of parentheses are the same, that means your answer is correct. If those are different, you have done something wrong and you need to start over. Okay? So now we factor out the common binomial. Well, here's our common binomial. So we're factoring it out, and we have, 3x minus 2. Okay, we just factored out. We have one of them. Now, what's left? 2x squared minus 3. Now, look to the answer on the right, or on the left, on grouping with an area model. Do we have the same answer? Yes. Does it matter the order that the parentheses are written in? No, it does not. Order for multiplication does not matter. Okay. Now, let's look at B. All right, on B, the problem is 8x to the 4th minus 40x cubed minus x plus 5. Okay, so first, we want to use our model, and we're going to say 8x to the 4th, negative 40x cubed, a negative x, and a positive 5. Okay, remember, first row comes first. So we have an 8 and 4 x's. And we have a negative 40 and 3 x's. So, what number goes into both 8 and 40? Well, obviously, the greatest common factor, 2 does go in there, 4 does go in there, but the greatest number is 8. Now, how many x's do they have in common? Well, they both have 3, so we have an 8x cubed. Okay? Now, on the bottom, we have a negative x and we have a 5. What do you think? Do they have any x's in common? Nope. But you have to remember, what number is in front of this x that we don't write? It's a 1. So, what could go there? The negative 1. Okay? Now, up top, you have to look at this first row. What number does 8 and 1 have in common, or 1 and 8? Well, the only thing that goes into both of those is a 1. How many x's do I have in common? Well, they at least have 1 in common, so we can just say it's an x. Now, we look at the last row. A negative 40x cubed and a 5. Now, I want a positive 5. When I multiply with the negative 1, my 5 is going to also have to be what? Negative. Here's how you can check yourself. Does 8x cubed and an x equal 8x4? Yes. Does an 8x cubed and a negative 5 equal negative 40x cubed? Yes. Does an x and a negative 1 equal a negative x? Yes. Does a negative 5 and a negative 1 equal a positive 5? Yes. So this is correct. So our two factors are 8x cubed minus 1 and x minus 5. But wait. I think we can simplify 8x cubed minus 1 by using the difference of cubes formula. Remember this? We take the cube root of 8x cubed and we get 2x. And we take the cube root of 1 and we just get 1. So, would this right here not equal 2x minus 1? 4x squared plus 2x plus 1? I think it would. Okay? Now, we come over here and we just bring this down. So this is an answer. Technically, the top one could be an answer as well. The bottom one is just more simplified. Okay? Alright, so now if I do it by grouping, which is so much easier, I think. Um, 8x4 minus 40x3 minus x plus 5. So remember, we group the first two terms. So we have 8x4 minus 40x cubed. We bring down our sign. And I'm saying x minus 5 instead of x plus 5, because if I were to distribute out this negative in the middle, I would need this to be a negative 5 in order to get this positive 5. Okay, so now we want to say 8x4 has 1, 2, 3, 4 x's. 40x cubed has 1, 2, 3 x's. So now I'm thinking, what do they have in common? Well, 8 goes into both, and they also have 3 x's in common. So now, if I only have an 8x cubed, but I want to get this 8x4, I have to have another x. If I have an 8x cubed, but I want a negative 40x cubed, I've got to multiply by a negative 5. Okay? Then I bring down my sign. Can you factor x minus 5 anymore? Nope. So guess what? Easy. You bring it straight down. Okay? Now, what number is between this negative sign and this parentheses that we just don't have to write? A 1. Okay? So now we factor out our common binomial. Well, you see the thing in common is x minus 5. Now, what do you have left over? 8x cubed minus 1. So that could be my answer. Now, if I wanted to, I could keep going and I could simplify the 8x cubed minus 1 just like we did on the area model using the difference of cubes formula by taking the cube root of both. So either one is correct. All right, now I want to skip over to number 14. And it shows a box, and we are looking for the volume, okay? Remember, how do you find volume? Volume equals length times width times the height, okay? Now, it tells us that an equation that could be used to determine the dimensions of this box given that the volume is 40 cubic centimeters, okay? So, we have this equation, and it wants to know what are possible strategies for solving the cubic equation to find the dimensions of the box. So, we are looking for the x's essentially. So, couple things you can do. You can graph. Let me pull up my calculator. Let's see. All right. So, the first thing it tells us we can do is we can graph x plus 2, and x plus 9, which is, let me start over. X plus 2, and x plus 9. And then we add the g of x, which is 40, because that's what it equals, okay? Now, here we would look for where it intersects, which would be our solutions. So, obviously, we cannot see 40, so we are going to want to zoom out. Let's see if I can get it up there for us. Not yet. I have no idea where this stopped recording. But what I did was I graphed the first bullet point right here where it's highlighted in gray. X plus 2 and X plus 9, and then I also graphed 40. And I'm looking at the intersection. So it would be a point here. A point here, a point here, and a point here. Now, if I wanted to, remember, what did we talk about last week? It's best to solve equations when they're set equal to what? When they're set equal to 0, right? So I have x plus 2, and x plus 9 equals 40. Well, what can I do? What is the one step I can do to make that equal to 40? Or equal to 0, sorry. Well, I can subtract 40, and I get this right here. Now, remember, when an equation is set equal to 0, that is when I can find my solutions, also known as my zeros, also known as my roots. Okay? So by looking right here on this graph, we can kind of tell. Oh, let me change that. There's one here, here, and here. Okay? So just by looking, and you can do this on Desmos.com as well. Let me actually go to that right now so we can see it better. So this is the calculator on Agile Mind. All right, so we have an X, we have an X plus 2, we have an X plus 9, and then we have that minus 40. Now, if we zoom in, here's a 0, and it's about negative 8.2. Now, where does this one hit? This hits exactly at x equals negative 4. This one hits at about 1.2. Okay? So our zeros here, let's see if we can move this. Yeah. Our zeros here would be x equals negative 8.2, negative 4, and a positive 1.2. Okay? So that's the easiest way to look for the zeros. Remember, you can always use the table, second graph. And if you wanted to, you could set it equal to 0 and you could just solve it. I recommend the graphing. Okay? Just another way to solve these problems. That's all we're doing. Just solving the problems. By graphing. How do I get this? By graphing, by solving, looking at the tables, all kinds of ways. I cannot get this to come around. Maybe it'll go away. Oh, Lord. Home. Oh, gosh. How do I get this off? Oh, no. Wait, is that it? Well, I don't know how to get it off. But anyways, let's go to number 18B. 18B. And I guess we'll just go right here. Okay. 18B. We're just factoring. X cubed, 6x squared, 4x plus 24. We want to do the grouping. So remember, split the first ones. So we have an x cubed and a 6x squared plus a 4x and a 24. Okay? 3 x's, 2 x's. They have how many in common? They have 2. Do they have a number in common? 1 and 6? Just be 1, so we can just leave it as x squared. Now, I want an x cubed, but I have this x squared, so I need an x plus 6. Now, we only have an x here, so you can't factor out anything, but
Evans, please come to the front office.
But I can factor out the number 4. So plus 4. What did I tell you earlier? Your parentheses have to be the same or it is wrong. Are my parentheses the same? Yes. So I factor out the common binomial and I have an x plus 6. What do I have left? X squared plus 4. Bam. That is my answer. Okay? Now, C is just doing a cube. Okay? So just factor out the cube using that sum of cubes formula that we did last week. Let's see what else. I think that's all I want to do on that. So now, what I want you to do is on Agile Mind, we still can't see it. But it's page 5 on your Agile Mind. So I guess I'm going to have to close this out when I get done videoing. I don't know. But it's page 177 in the workbook. So all we're doing is long division again. I know you love long division. Okay. So it tells us that P of x is equal to x cubed plus 6x squared minus x minus 6. So on part A, we're dividing this by x plus 1. So first, all we're doing is the long division. Now, remember, first term on the inside divided by first term on the outside. X cubed divided by x leaves me with an x squared. Then we multiply. X squared, x plus 1, and I get x cubed plus x squared. We subtract. Those cancel, and I have 6 minus 1, which is a 5x squared, and I bring down my negative, not a negative 5, I'm sorry, negative x. We start the process over. 5x squared divided by an x leaves me with a 5x. Then I multiply 5x squared plus 5x. We subtract. These go away and we have a negative 1 minus 5 more, which leaves me with a negative 6x, and I bring down my negative 6. Now I'm going to have to erase this because I don't have any room. Negative 6x divided by an x leaves me with a negative 6. Negative 6 times x plus 1 is negative 6x minus 6. These are the same, so they cancel. So, do I have a remainder? No. So, up here I want you to write R0 like you did in the 4th grade. Now, what we're doing is the remainder theorem. Okay? So, here's how you do this. We do not have a remainder. It is set equal to 0. What did we divide by? We divided by x plus 1. Remember, that is called my factor. I need my 0. So, I say x plus 1 equals 0. And I solve. X equals negative 1. This is so easy, guys. What you do now is you take that x and you plug it back into the original equation. All right. Did you see what I did? I plugged it in. So, a negative 1 cubed is a negative 1. 6 times negative 1 squared is a positive 6. And a negative 1 and a negative is positive 1 minus 6 is a negative 5. If I combine all those, I get 0. What was my remainder? 0. So, here's how you know it's correct. If your remainder and your answer, when you plug in your 0, are the same, then you are correct. Am I correct? Yes, I am correct. Okay? Now, let's do B. We're using the same problem, except this time we're dividing by x minus 3. So before we even start, I want to find my 0. X minus 3 equals 0. I'm going to add 3. So x equals 3. So go ahead and let's plug in 3 to my original problem. When I plug that in, and I'm just plugging it in on my calculator, I need to get a 72. I put everything in at once, okay? I made it look just like this. So I got 72. So now, when we do long division, what does our remainder have to be for it to be correct? 72. That's why it's called the remainder theorem. So, I'm going to divide. It goes x squared times x minus 3 is an x cubed minus 3x squared. We subtract. And I have a negative 6 minus a negative 3, so that's a positive 9x squared. We bring down our negative x. That goes in 9x times. So that's a 9x squared minus a 27x. when we subtract, we are left with a 26x minus 6. That goes in there. 26 times 26x minus 78. When I subtract, I have negative 6 minus a negative 78, which leaves me with the remainder of 72. Since this matches, is it correct? Yes, it is correct. So this was kind of a hard lesson to teach on the iPad. So please let me know if you have questions. I'll try my best to help you through the computer. If we need to, we can always do a Teams call. Just let me know, please. I'm always here to help with whatever you need. Okay? Have a great day.